Rectangle ABCD. E is the midpoint of AD. The area of triangle BFC is 8 square centimeters. Find the area of the purple triangle and the rectangle. Before we dive in, let's first introduce a common model. It looks very much like an hourglass, so for the sake of simplification, let's call it the hourglass model. This model has two conditions. 1. There needs to be a set of parallel lines. 2. The intersection of the two lines should be between the parallel lines. Let's start. Connect 2 points on the same side, and the two triangles that appear have areas of A1 and A2 respectively. They share the same height, so their area ratio is the same as the base ratio. The same logic applies to the other side. A previous video proved that when diagonals of a trapezoid are connected, the areas of the triangles on the left and right sides are equal. This is the butterfly model. If you haven't seen it, you can click here. We simply apply this, confirming that A2 equals A3, which means we can establish that the ratio between OA and OC is the same as the ratio between OD and OB. If you understand similar triangles, you can also deduce that the ratio of the lengths of the upper and lower line segments is the same. Of course, the ratio of the heights of the upper and lower triangles is also the same. Let's continue and look at the relationship between the area ratios of the upper and lower triangles. First, write down the method of calculating the area. Since they divide by 1/2, the result remains the same. In conjunction with the previous teaching, we can replace any pair of figures. When they are replaced with the same value, we can draw another conclusion. The area ratio of the two triangles is equal to the square ratio of the corresponding sides. Returning to the problem. E is the midpoint of AD, so the ratio between ED and BC is 1:2. With this ratio, we can break through from here. The ratio of the area of the purple triangle to the area of triangle BFC equals the square ratio of ED to BC. Plug in the corresponding numbers, we can easily find that the area of the purple triangle is 2 square centimeters. Continuing with this ratio, this time with the triangles on the same side. We can easily find the area of triangle DFC to be 4 square centimeters. In this way, we know exactly half of the rectangle, and the area of the rectangle naturally follows.